Hello everyone. So, in the previous video, we saw how to interface with actuators. And in this video, we are going to see one of the most interesting topic. And it is one of the very important topic also. That is pulse width modulation. So, pulse width modulation or PWM is a common technique used to vary width of pulse in pulse tray. PWM has many applications such as controlling servo motors and speed, limiting the effective power of motors and LEDs. So I want you to focus on this part, that is limiting the effective power. So for an example, if you have a motor and you want to control its speed, how will you do that? So you may say, okay, I will reduce overall power. But in case of microcontroller, in case of our digital devices, there are only two states, that is 0 or 1. So if you are controlling the DC motor, 5-volt DC motor using Arduino, how will you control the speed of the motor? So basically answer is pulse width modulation. Here, here, we will control the effective power that will be supplied to the motor using this pulse width modulation technique. So basically what we are doing, instead of providing the high signal continuously, what we do, we will provide the signal in the pulse, in the form of pulse. So according to the width of the pulse, the effective power will change. So in pulse width modulation, we use some terminology. First is on time. So on time is a duration of time signal where the signal is high. Off time, duration of time signal is low. Period, it represents as the sum of on time and off time of PWM's signal. What is duty cycle? It represented as percentage of time signal that remains on during the period of PWM. What does it mean? So consider T on is on time and T off is off time. And the total time is T total. So duty cycle will be T on divided by total. So it is the percentage of time on which or during which the PWM signal is high. So by controlling the duty cycle, we can control the effective power. So that's it. This is the entire concept of PWM. So though there are many techniques from which we can achieve the PWM, but core concept remain the same. Instead of providing the continuous high or continuous low, we will provide the signal in terms of pulse. And again, effective power we control using the control by controlling the width of pulse for a particular time. Okay, so duty cycle is a percentage of time for which pulses are high in PWM signal. And we control effective power by controlling the duty cycle. So in Arduino, to achieve pulse width modulation, we use analog write, analog write function. So analog write take two arguments. One is pin number, second one is value. And value can vary between 0 to 225. So you may ask, like every pin is capable of doing pulse width modulation in Arduino Uno? Answer is no. Only 6 pins are capable. So if you see a small tilde symbol in front of any pin, that pin is capable of doing pulse width modulation. So now let's quickly jump on to the Tinkercad and do one small simulation from which you will understand about the pulse width modulation. Okay, and in this example, I am gonna use one more function, that is map function. So later in simulation, I will explain it to you. Okay, so now let's quickly jump into the Tinkercad. So here I am on my dashboard, create a circuit. So I hope by now you are able to make a circuits on Tinkercad. Okay, and I advise you to make as many circuits as possible, because using the best part of Tinkercad is you can't break anything. It is just a simulation, correct? And there is no loss. It is completely free. So I highly suggest, whenever you get time, just try to make new thing on Tinkercad. Okay. So I have one LED. I have one potentiometer. So I will be copy pasting the code. So I will, what I will do, I will copy paste the circuit also. Why? So unlike our computer programming, the microcontroller programming vary, because we are interacting with actual signals. So on 11, my LED is connected, and from A0, I am taking the signal from potentiometer. So it is anode. So let's connect this to the pin number 11, and what I will do, I will use one resistor here to connect with ground, and this circuit. So I explained it to you before. Middle pin will go to A0, one pin will go to power, and another one is go to ground. Okay, I hope you remember this much. So now let's quickly copy paste the code and see. So, so I want code in the text format. Continue, Control A, Control V. Okay, so now first let's understand the code for a bit. Okay, another thing I want to do, I will reduce this to around 500 ohms. Okay, uh, so I am defining A0 as an input. Reason being, I am taking in the signal. I am beginning the serial monitor on the baud rate of 9600, and I am defining 11 as an output. Okay, after that I am reading the raw data from A0, and I am mapping that data. So analog data will vary between the 0 and 1023, correct? But but our analog write can take data between the 0 to 225. So I will map that using the map function. Okay, so now let's quickly start the simulation. Okay. So it is nothing sometime to the problem. So as you can see, the brightness of LED is changing as I am changing the value. If I am at the maxima, brightness of LED is maximum. Again, what I will suggest, let's make it even less so that it is clearly visible. Though it is danger, it is showing here also it is danger, but fine. See, I am increasing the resistance value. The brightness of LED is also changing. Okay, here brightness is even low. Here again even lower, lower. And at this particular point, LED is almost in off state. So if you do it using the real LED, you will find the clear difference. So I hope you understood the pulse width modulation and how to control the brightness of LED using this circuit. So that's it for this video. See you in the next video. Till then, bye.